Welcome back to my channel again. So today we're going to do a talking video, and the subject is, or the topic is about what the previous video we talked about, the big crunch. So today we're going to talk about the ending of the big crunch as a continuity. So what's the ending of the big crunch? That already, if you watched that video, you saw what I talked about. This, the ending of the big crunch will get filled with radiation from stars and high energy particles. When this is condensed and blue shifted to higher energy, it will be intense enough to ignite the surface of the stars before they collide. In the final moments, the universe would be one large fireball with a temperature of infinity. Just let that sink in. It will be a large fireball with a temperature of infinity. And at the absolute end, neither time nor space would remain. So that's the end of the big crunch, when the dark matter start to go back. Right now it's expanding. We don't know whether it's still expanding, but it's gonna reverse the course. It start to pull like gravity, work together with the gravity and pull the universe back up to where it started. That's what the big crunch is about. It's when I talk, I get this. So the big crunch is actually hypothetical. It's not something that is confirmed. It's a hypothetical scenario for ultimate fate of the universe, in which the expansion of the universe eventually reverses. That's what's dark matter. Because around 3 billion years to 7 billion years ago, dark matter overtook gravity and the universe started to accelerate, expand fast. Before that, gravity was evenly balancing, pulling it, slowing it down. But now it exceeded gravity. I have a problem when I'm talking. So the expansion of the universe eventually reverses. That means the dark matter now starts to become gravitational, pulling back, and the universe recollapses, ultimately causing the cosmic scale factor to reach zero. Now I'm gonna go to cosmic scale factor. What is cosmic scale factor? That is what the scale factor of the universe today. In the beginning it was 1, 0, now it's supposed to be 1. We can define a scale factor such that S1 is equal to day and S0 at the moment that the universe, the existence of space and time began. Okay? That's what we call scale factor. So what is the cosmic scale factor? Yeah, that's something different to redshift. So we're talking about the end of the universe here, but it's actually hypothetical. It's not real. I mean, it's hypothesized that this can happen. So I'm gonna tell you further what a cosmic scale factor is. It's actually a mathematical quantity that describes the changing separation of 2 points. So as the universe expands, it can be thought of as a time-dependent magnification factor. That's what we call cosmic scale factor. So the universe will end like that, hypothetically. but it's not something that's really confirmed. That's how it will end. So I put down some notes, guys, about this. So today I'm gonna talk more by asking questions than giving the answers to you. So now already I've told you what the scale factor is of the universe. Now the next question that I'm going to put forward is, what is the cosmic scale factor to redshift? So the conical redshift, I don't know whether I'll draw it. I have to wrap up this stuff for me. Excuse me. As usual, we have to do this also. And conical, when it means conical, I'm drawing it, guys. It's something like this. Right? It's conical, you know, a cone. So here it depends whether it's starting from here, going this way, going this way. Let me just see what they're actually saying. So so we're talking about what is sorry, I just lost the point. What is the cosmic scale factor to redshift? The conical redshift scale factor relation that's mathematical. I don't think you need to know that. 1/2 is equal to 1 plus z is a key element in the standard lambda CDM model of the Big Bang cosmology. So, is our universe redshifted? I think you know what's redshift if you're following me in the videos. So redshift means what? When the wavelength is lengthening and then it's losing energy and moving away. The galaxies are going further and further from Earth, you know. So is our universe redshifted? Now the galaxies are moving away from Earth because the fabric of space itself is expanding. Okay, the galaxies are moving away from Earth because the fabric of space itself is expanding. Now the dark matter is expanding, you know. So while galaxies themselves are on the move, the Andromeda galaxy and the Milky Way, for example, are on a collision course. It's estimated that around 4 billion years they're going to collide, Milky Way and Andromeda. And what will happen after that is not known. There is an overall phenomenon of redshift happening as the universe gets bigger. So let's go further with more questions. What is the evolution of cosmic scale factor? Now, the evolution of the scale factor is a dynamical question determined by the equations of general relativity, which are presented in the case of a locally isotropic, locally homogeneous universe by the Friedmann equations being its current value, which is just Apple's law. It's increasing with time. You understand what I say? What is the evolution of cosmic scale factor? I talked to you about the scale factor. Yeah, I've just read to you before. Is space a total vacuum? That's the most interesting part now we're going to talk about now. Outer space is not completely empty. It's not completely empty. It's not a vacuum as such. It's a near perfect vacuum, but it's not really a vacuum. It contains a low density of particles, predominantly a plasma of hydrogen and helium, as well as electromagnetic radiations, magnetic fields, neutrinos, dust, and cosmic rays. So it's not really empty. Some small elements of these things are there, but it's a vacuum, it's assumed to be vacuum. In a small scale, for example, it's a place where like sound cannot travel. Light can travel, sound cannot, because the mediums, they are scattered, they're very small, but they are there. So we have answered that question. Is space a total vacuum? No, it's not. Some things are there, in small quantities, the ones that I've read to you. The helium, the hydrogen, electromagnetic radiation, magnetic fields, neutrinos, stars and stuff. Is time finite or infinite? Is time finite or infinite? Interesting. What will you say if somebody asks you this? Now the answer to that is, as a universe, a vast collection of animate and inanimate objects, time is infinite. Animate and inanimate, time is finite. Even if there was a beginning and there might be a big bang end, it wouldn't really be an end. It wouldn't be really an end, which means time will continue. I don't know in what respect it will continue. If there is a big bang, not a big bang, one is the crunch, dance. So the energy left behind will become something else. The end will be a new beginning. So this is like when you're asking the question, how was Big Bang born? Yeah, it's being answered like this, hypothetically, or maybe this really, me, I also thought about this. I said there must have been something before the Big Bang. And according to this theory here, it says that if time is finite or infinite, as a universe vast collection of animate and inanimate, time is infinite. Even if there was a beginning and there might be a big bang end, it wouldn't be really the end. It would be like a beginning, the energy left, there will be energy left, and this energy will be something else. Like the end will be a beginning. So isn't this really what happened? Isn't it safe to say this is a universe without beginning, without end? It's a process that goes up to the climax, then goes back to zero, then goes to the climax. So like if you're drawing something like a loop, it's not a loop actually, like a cycle, a pendulum, which keeps swinging back and forth. Yeah, you can describe the universe like that. But when I think at some point maybe there will be accidental happenings, so some things evolving that can change the course of action. Like the universe won't be moving along the same thing, like it's expanding and contracting and expanding and contracting. Yeah, and this thing takes billions of years. It's not that it's gonna take a single 1 year, billions of years to happen. But if this really happens, at some point something might come up, another process, maybe properties will change, and then it will no longer be the same case, like the Big Bang will be there, or there will be multiple Big Bangs or small Big Bangs, and when you put that together, it will result to something else. So are we predicting the death of the universe? Will it really die? So you know that energy cannot be destroyed, right? It can only change from one state to another. It will keep evolving. So this is to say that energy has always been there. And if energy is mass times c squared, that means matter has always been there. So matter is something that has weight, can occupy space, it has gravity, pulls. So it's difficult really to say whether this thing will end like that or they continue forever. Forever is a very misleading one here, because forever is only a piece of our mind. What's really forever? So guys, today we were talking about these cosmological things. I've talked to you about this in the previous video, and today was like a further clarification or repeat of what we said, but in a different way with some definitions along with that. So guys, drop comments below if you know this subject better than we do, and we work together. Okay guys, thanks for watching, and keep tuned, keep on tuned into this channel as we bring you more and more. We are not fixed. Sometimes we talk about this, sometimes we talk about the others. Okay guys, thanks for now for watching. Please share, like and subscribe to my channel. Please subscribe to this channel. Bye. See you in another one.